Hello, in section 8.3, we are going to look at how we evaluate trig integrals. So to evaluate trig integrals, we're going to need to review some trig identities that are going to be very useful in these evaluations. The first is remembering our Pythagorean identities. Our Pythagorean identities are sine squared x plus cosine squared x equals 1. And then the other two come from first dividing everything by cosine squared. So everything divided by cosine squared would be tangent squared x plus 1 equals secant squared x. And the other would be dividing everything by sine squared x. Dividing everything by sine squared is 1 plus cotangent squared x equals cosecant squared x. Other identities, really good to know, are the double angle identities. These have already come up in an area between curves problem from earlier videos. So as a review, the double angle identities are sine 2x equals 2 sine x cosine x, and cosine 2x has three different ways we can write it. We can write it as cosine squared x minus sine squared x. We can write it as 2 cosine squared x minus 1. And we can write it as 1 minus 2 sine squared x. Three different ways to write cosine 2x. And the last, these will come up quite a bit as well, are the power reducing / half angle identities. These formulas are really just the double angle identities rewritten, where we know cosine 2x equals these three things. If we rewrite solving for either the sine squared x or the cosine squared x, we get sine squared x is equal to 1 minus cosine 2x over 2. And solving for cosine squared x, we get cosine squared x is equal to 1 plus cosine 2x all over 2. And these formulas will be very helpful in many integrals. In section 8.3, we're going to learn how to integrate a bunch of different forms. So in the notes section, we have a nice tips for integrating document that will be useful in getting started on these integrals. I will not read it out, but you can find this document in the 8.3 module and look it over. But in the next few videos, we will actually use these tips and learn how to integrate various trig integrals.